Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam Harris.
And I'm Kim Montague.
And we're here to suggest that mathematizing is not about mimicking or rote memorizing, but it's about thinking and reasoning, about creating and using mental relationships. That mathematics class can be less like it has been for so many of us and more like mathematicians working together. We answer the question, if not algorithms, then what? All right, so today a quick thank you to Tara Buck on Twitter who said, I love how you all explain things and present the problem strings to get me thinking. Well, thank you, Tara Buck. We love problem strings and we'll be doing one in this podcast. Yes.
So speaking of problem strings, in preparation for today, we went back and listened to the recording from last week's episode. And oh my gosh, y'all, I am laughing at how much I was on the struggle bus for that last problem. It was a real moment for sure. And Sway Pam was so patiently trying to help me with 3/4 and nickels. And I was listening back. I thought, how could you not hear that? Like, how could you not just hear what she was trying to say? But the truth is, I was already trying to think of something else and I could not even follow where you were going, right?
Yeah,
and
totally.
That actually speaks to what happens sometimes with students that we're trying so hard to guide.
Yeah, so let's just replay that moment a little bit. This is honestly going to be a little bit more embarrassing for me than for Kim because we were talking about the problem 3/4 minus 3/5. 3/4 minus 3/5.
Yep.
And I basically was forcing you to think in nickels.
Yeah.
Right? Like I was forcing it. And even worse, because I wouldn't let you think. I talked too fast. Too much. And as we were listening, so we just re-listened to the episode, I was like, oh, Pam, too fast. Let her think. Yowza. And even worse, I was forcing a strategy. So again, the problem was 3/4 minus 3/5. And I was trying to get you to think in nickels. And so I said, well, can you think about 1/5?
Yeah. And it's interesting because normally I think I would tell you, just wait, right? I would hold up my finger to pause you. But on a podcast, I wasn't sure how that would feel. So I just went with it.
Right. So we've just been talking about, like, go ahead and tell me in the podcast, even, like, we'll figure it out. But it's so important to give people time to think.
Yeah.
And to not just funnel them down the path that you're thinking about. I was thinking about nickels. I was forcing you to think about nickels. I know instantly when we'd done the problem, 3/4 minus 3/5, you instantly thought, do you remember?
75 cents minus 60 cents.
I mean, bam, it was just there. And then I was like, but let's think about nickels. And you were like, okay. And then I didn't give you a chance to think. I just funneled you down the path that I was thinking about. Instead, we're suggesting that we want to work to pull students out. We want to work to pull out what students are thinking, not take them down the path that you're doing. So, hey, it's real. You watched a real moment where I didn't do what I am advocating to do with teaching. So I'm going to own that. I'm going to admit it. We're all then going to get better because we're going to be more clear about what we're advocating for so that we can all get better at it.
Yeah. And so it's interesting because in retrospect, I probably should have told you that I needed time, not help.
Oh, so good. And if you don't recognize that, go check out episode 40 where we talked about homework and we talked about that very idea. Do kids need more time or do they need help? And in that case, you just wanted me to breathe for a minute and give you a chance to just think a little bit instead of ramming my help down your throat. Right. Thank you, Kim. Kim is very patient with me and I appreciate that. All right. So also in the last episode, we asked you guys to think about denominators that make sense to use with money. We had been doing a lot of fraction problems where we said, think money. Just like I just said, I was sort of forcing Kim to think about nickels. She wanted to think about cents. And she'd already solved the problem, right? In fact, if I could just mention, it's also one of the things that we're kind of advocating with kids is that once they've solved the problem in their best way, then it's not always about forcing them to find just like any other way. Like then we want to do things to help them think more efficiently, more sophisticated, but recognize like that they'd already solved the problem. So we've got to kind of get out of that. Well, I've already got the answer kind of a thing. And oh God, it's walking this fine line between recognizing, that was fine. Let's get a little bit more sophisticated. It's not always just about thinking about a different strategy.
Right.
Anyway, blah, blah, blah. So we ask you to think about denominators that make sense with money. So if you haven't yet, I just kind of went off on a beaten path where maybe you were thinking about it. If you haven't yet thought, what denominators of fractions do make sense to think about money, to like use coins and money to help you reason about fractions and fraction equivalence. So if you haven't thought about that yet, maybe pause and think a little bit. So, which denominators do work well for a money model? Kim, you got any?
10.
Start
Yeah.
10.
10 and 20.
Okay.
100.
Cents, yeah.
Yeah.
So, in fact, let's
100
back up. So, 10 was sort of dimes,
Mm-hmm.
20 would be nickels,
Mm-hmm.
100 cents. Any more?
4.
For quarters.
Quarters.
Okay.
Uh-huh.
So, those are all coins. Did we get them all? Pennies.
No. But also 2.
So we got the coins maybe, but now we've got other denominators that make sense. No,
Yep.
2, that's 50-cent piece.
Yes.
You're right. One more
Yep.
coin. Okay.
5.
5. I don't think we have a coin for 20 cents. We don't in the United States. We don't have a 20-cent coin. Maybe somebody does. I think actually there are 20-cent coins. I just read something on Twitter about 20 cents. Anyway, okay, so
Interesting.
So 5 20-cent coins, that could be a thing. Okay.
Yep.
And
25.
We definitely don't have a 4-cent coin.
Right.
Okay, but that would help if we had a denominator of 25, we could think about 4-cent chunks of 4 cents. Okay. Anything else?
50.
50. We definitely don't have a 2-cent piece either, but we have 52-cent pieces.
Yeah.
And what did we get them all, do you think? Yeah, I think so.
Yeah.
Somebody's going to tell us if we didn't. So what do all of those have in common? Those are factors of 100. And so they're really nice to work with money because they divide evenly into 100. And so when we see those denominators in fractions, then we can think money to help us think about equivalencies.
Okay, so great. All right, last week you gave me problems. And we kind of started a problem string. So today let's wrap up that problem string that we started, but this time I'm going to ask you some questions.
Oh boy. Okay. So you're going to give me plenty of wait time.
I will.
Okay.
All right. Do you have something to write down?
I have a pen. I have a pen. I do. I have a pen and pencil pen and pencil. I have a pen and paper in case I need it. Just in
case. Yeah.
Okay. Just in case.
All right. 1/25 plus 3/4.
1/25 plus 3/4. So I'm thinking 1/25 feels like 4 cents because 25 times 4 is $1. So I'm going to think actually in decimals. I'm going to think about 4 cents. So I've just written 0.04. And 3/4 I could think about as like 3/4 or 75 cents. And so that's 79. So 4 cents and 75 cents is 79 cents. So then I can go back to fractions if you want me to. And that's 79 hundredths. 79 divided by 100, 79 hundredths. Yeah?
I like that you were thinking about decimals.
I mean, I think I'm really glad now that I'm done with the problem because now that I'm looking at 79 100ths, that's not going to do, I'm not going to be able to do a whole lot in other coins. And so me too.
Right.
Nice.
Cool.
All right, bring it on. Give me another one.
All right. 2 2/5.
Oh, mixed number. Okay, 2 2/5. Okay.
Minus 9/20.
Minus 9/20. 2 2/5 minus 9/20. So the first thing I'm going to talk out loud. The first thing I'm considering is, do I want to stay in mixed numbers and deal with like the whole 2 2/5 minus 9/20, or do I want to just consider 2/5 minus 9/20? And as I consider that, I'm thinking to myself, 2/5 is almost a half, and 9/20 is almost a half. So I'm not actually really clear how those are going to pull out. I think 2/5 is greater than. No, I don't know actually. Like they're both so close to 1/2.
Yeah.
And now my brain's shutting off a little bit going that direction. Yeah. So since they're both so close to 1/2, I'm not really clear if I can just do the 2/5 minus 9/20 and then tack back on that whole 2 that we had. So I might just stay with the whole 2 2/5 to begin with, and then I'll kind of reevaluate after I do that. So I don't know, for some reason, maybe it's because you're on the line. I'm thinking decimals again. Oh no, no, I was going to think decimals, and then I looked at the 20ths, and so then I'm going to back up. The 2 2/5 was screaming at me 2.4. But then the 9/20, I was like, ooh, but no, that's just screaming nickels. So I'm actually going to go nickels. So 2 2/5 is like two. Let's see, the whole two, like $2,
Mm-hmm.
and then 2/5 nickels. 2/5 nickels. I am going to kind of go cents or decimals because I'm going to think about 0.4 or 40 cents.
Mm-hmm.
And 40 cents is 8 nickels. So it's like I've got 2 and 8/20 minus 9/20. Oh, bam! Now I can compare the 8/20 and the 9/20, and so the 2/5 is smaller
Yeah.
than the 9/20. That was noteworthy to me. So let's see, 2 and 8/20 minus 9/20. I'm going to go ahead and I'm thinking about 2 and 8/20 on a number line, and I'm going to go ahead and subtract 8/20 to get to 2. But I was supposed to subtract 9/20. I've already subtracted 8/20 to get to 2, so I've got to subtract one more 20th. And 2 minus a 20th is 1 and 19/20. So I say my answer is 1 and 19/20.
That is so interesting to me.
Not what you would have done?
Well, I feel like I think so heavily in decimals that it's interesting because like last time I was struggling with the nickels, but when I look
And I
at,
went to nickels, and you don't like that.
well,
Okay, so
when I see 9/20, I immediately think
oh, wait. Don't can I try
Yeah,
to think about
yeah.
it? Okay, so hang on. So 9/20. So 2 and 2/5. It was instantly 2.4 for me. I don't know why
Yeah, yep,
I've done that
yep.
enough. So 9/20. Ooh. Okay. 10/20 is 50 cents.
Mhm.
So 9/20 is 45 cents.
Yeah.
Oh, and you were right there, right off the. So you were like, I can compare those. That because it's 0.4 to 0.45 or 40
Yeah.
cents to 45 cents. Okay. And so then I could take $2.40, subtract 45 cents, and also get $1.95,
Uh-huh.
which is like $1.19. Okay. Thanks
I
for
would
letting me
I would
scream at you to
That's
let
okay,
me
and it's
solve
okay.
that.
I would never have thought of 19/20. So interesting. Hey,
Huh.
so one of the things that you said earlier, I'm going to go back to that problem. You said 1/25, and you said that was 4 cents.
Yeah.
So it's interesting to me because I can get on board with a fourth is 25 cents, right? That.
A fourth of a dollar is
Mhm,
25 cents.
mhm.
Hey, and let me just point out really quickly, if you've listened to the episode where we talked about the 5 interpretations of rational numbers, we are leaning heavily on the interpretation of fractions as operators right now,
Yeah.
because Kim was just saying a fourth of a dollar, and she said it's like you said, I can think of a fourth of a dollar as 25 cents, like a $quarter is 25 cents, a quarter coin is 25 cents, and you were asking about it 1/25th, is that
Yeah.
right?
Yeah.
So are you asking me like how am I thinking about 1/25th of a dollar?
So I just think it's interesting that what I've seen sometimes kids do is think about 1/25th, and their gut reaction is to call that a quarter because it has the 25 in the denominator,
Mm-hmm.
right?
Yeah.
And so
Yeah.
sometimes they want to call a fifth a nickel, right? So I just.
Ooh, slow that down a little bit. Yeah, they'll look at a fifth and they'll say to themselves, "Ooh, there's that 5."
Mhm.
And so they think about that as a nickel, but really a fifth of a dollar is 20 cents.
Right.
And so then where's the nickel? That's the 20th. A 20th of a dollar is a nickel because there are 20 nickels in a dollar.
Yeah.
So I think what you're bringing up is sort of what we call the reciprocal relationship.
Right.
If I think about fifths and 20ths, those are related because 5 times 20 is 100. But I have to sort of parse out which represents the nickel and which represents a fifth of a dollar or
Right.
20 cents. Yeah. And so like when we purposefully did the problem 1/25th plus 3/4 because there's those two denominators. There's that 25th in the 25 in the denominator and 4 in the denominator. And so parsing that out can be tricky, which is why we give students problems with both of those denominators. Now, we
Right.
don't do that necessarily right off the bat. We might give them problems for a while, not forever long, but long enough that they get really used to dealing with thinking about fractions as operators and coins before we put up in front of them that reciprocal relationship of fourths and 25ths, or that second problem we did of fifths and 20ths. This is so hard to do over like audio. I hope this is translating. You guys have to let us know on social media if it's totally translating when we're saying these fractions, because I'm like, a little crazy. Hopefully it is. Cool.
Well done, you. Well done.
Cool. Anything else on that? Did I talk about that inverse relationship enough?
Yep.
Cool. All right. So this week and last week, we talked all about using a money model to help us really think and reason about fractions. In doing that, I want to be really clear that one of our main points isn't so much getting kids great at adding and subtracting fractions. That's actually kind of a byproduct. Our goal really is to get kids thinking about equivalent fractions.
Right.
We're building equivalence by having kids add and subtract fractions using a money model, using this model that should be somewhat familiar with them, or we want to help it become more familiar with them. And so using that operator meaning where they can think about a half of a dollar, a tenth of a dollar, or a 20th of a dollar to help them think and reason about equivalencies. Our main goal here in using this money model is to really build equivalent fractions and the sense of what it means to have equivalencies with fractions. But in these 2 episodes, the only denominator that we've been working with, or thing denominators we've been working with, are factors of 100 because
Right.
those work well with a money model. So next week, we better do some more with fractions that have denominators that aren't factors of 100. And let's do that. We will use a different model and we'll get even better at equivalencies, at getting kids really thinking and reasoning about equivalencies with yet a different model. All right, so remember to join us on Math Strat Chat on Facebook, Twitter, or Instagram on Wednesday evenings, where we explore problems with the world.
If you find the podcast helpful, please rate it and give us a review. That way more people can find it wherever they get podcasts.
Yeah, and don't forget that we are collecting your questions that you want answered. Send those to kim@mathisfigureoutable.com, and we will tackle them in an upcoming episode. So, if you're interested to learn more math and you want to help yourself and your students develop as mathematicians, then don't miss the Math is Figureoutable podcast, because math is figureoutable.